So exponential growth tells us that the graph increases rapidly. Okay, I'm going to use red for growth today. All right, so as we take a look at growth, what word in our definition here would indicate to us that this is growth? Yeah, increase. Okay, so increases rapidly. So this growth is actually going to start off growing really slow, and then it's going to grow faster and faster as we go. So the way that this graph looks, I'm going to draw just a very small graph. It's going to take about 2 lines here. Is it starts off low, and then as we grow, it grows and it goes up, 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 up really quick. Something that happens with exponential growth is population. So when there's fewer people, our growth starts really small because there's not that many people to have people, but as we get more and more and more people, it starts growing faster and faster and faster as we go. So that's where we really see exponential growth is with population. Okay, exponential, we should go back to that word. I forgot to talk about it. What word do you kind of see in that word exponential? Omar, put away your phone. What word is in the word exponential? No one? So if we cover up that suffix? Exponent. So that's how this has worked. It's an exponent. So we say y is equals, and we have another number b. This b will be a number, but then it's taken to the x power. We haven't done one of those yet where x is the exponent. Okay. With exponential growth, our b, the number we're taking to the x power, is greater than 1. So b is bigger than 1. Okay, in order for growth to happen, that b has to be bigger than 1. All right, so that's exponential growth. Our other one we have is exponential decay. Okay, for decay, I'm going to use blue. And decay is kind of like the opposite. It starts off really high. It drops, 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 and then eventually it just kind of lowers down. Okay, we talk about decay a lot with like radioactive decay. When you think about radioactive decay, things will decay a half-life. It'll be half-life, half-life, half-life. Eventually, half of a small amount is a small amount, but when you have a big amount, it gets half easy. So rather than the graph increasing rapidly, the graph will decrease rapidly. All right, so again, it's the same equation, y equals b to the x power. X is the exponent, so we're actually going to have a number for the b, and we'll switch out that exponent with those numbers. But this time, b is between 0 and 1. So 0 is our lower bound. It can't be 0, because if it's 0, the answer would just be 1. But it's less than 1. It's somewhere in between 0 and 1. All right, so we're going to do 2 problems. So here's our first problem, problem 1. We have the equation y equals 2 to the x power. So first thing I should be able to do is just based on this equation, I should be able to decide, is this a growth or a decay? When I look at that B, that number in the front here, this is where I'm using my yellow, just to use a separate amount, that 2, is that 2 bigger than 1, or is that 2 between 0 and 1? It's bigger than 1. So if it's bigger than 1, is that growth or decay? Growth. Okay, again, that's going to be something that you do in the first part of your problems. All right, so as we do this, we use a table, x, y. Now for exponential growth and decay, there's not a starting point, there's not a vertex like there was for I-5 and I-6. So we just use -3 through +3. So -3, -2, -1, 0, 1, 2, 3. Okay, and using those 7 numbers is going to just help us graph out what it will look like, so that way we can make a nice graph. Alright, so we're going to use our calculator. We use decimals just like we do on everything else. Okay, this time we're changing the exponent. So as we look at this, we're looking for that exponent button in decimals. Okay, so our equation here is 2, and then I need to use the power of. I use this AB button, not A squared. I'm going to do the power of, and the first number we're putting it to the power of is -3. And we get 0.125. Today we're going to round to the nearest hundredth, so I know that's only 3 numbers, so we could write it all out, but when you type in your work. So are we going to keep it at 12 or change it to 13? What does that 5 tell us to do? Change it. Yep, so 0.13. Okay, now I'm deleting that -3 and we're putting in -2. We get 0.25. That's already rounded to the hundredth, or it's already just a hundredth. It's not rounded, so we can just keep the whole thing. Change -2 to -1. We get 0.5. Delete the -1, make it a 0. We get out 1. Delete the 0, put in a 1. We get 2, because it's 2 to the first power. You should be able to do this one. 2 squared is 4. Anyone know 2 to the third power? 8. Okay, now that we have that, go ahead and glue in your first graph off to the side there. And we're going to plot those points. So if you want to glue and you want to work ahead, you can. Dylan, can I borrow that after you're done? Thanks. Alright, and then we're just plotting those points once you get that glued in. So, give you about 15 more seconds to get that glued in. Alright, so as we graph, we're going to have to do some estimation where we think these points are. So the first one is -3, 0.13. So we're going left 3. 0.13 isn't going to even be halfway, but it is positive, so it's just a little bit above the 0. So just a little bit above. Okay, -2 is 0.25. Again, it's not even halfway. We just want to make sure it looks like it's a little bit above the other one. It's increasing a little bit. -1 is 0.5. That's halfway. So that's a good way to double check. These ones should be lower, and then it should be increasing a little bit. So it starts off low, negative 3, 0.13, negative 2, about a quarter of the way, then halfway. Now we're at 0, 1. Then we have 1, 2, so right 1, up 2. And then 2, 4, so right 2, up to 4. And then we have 3, 8. And 8 isn't on the graph. We can guess about where 8 would be. 3, so here's 6, so 7, 8-ish. I'm going to put it there. It's off the graph. So this one is growth. I'm going to use red because that's what I used for growth earlier. So as we look at this and we connect these lines, it's going to make a curve. So as we connect these lines, we don't want to connect them with straight lines. We want it to be curved. And as this continues to the left, it's going to continue to go down, 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 but it's never going to go into the negatives. It's going to get almost like we see, like it looks like it flattens out at 0. And as it goes up, 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 it's going up really fast at this point where it looks like it's almost going straight up, but not quite. So as we talk about our domain and our range, domain, we're looking left to right. So does this graph keep going to the left forever? Yep. Does it keep going right forever? Yeah, it's going up, but it's going up to the right. So if it keeps going left and right, it's both directions. What do we say? All real numbers. Okay, and then for our range, range is our y's. That's our up and our down. So this one's kind of tricky. Does this one keep going up forever and ever and ever? Yep, it keeps going up. Now, it keeps going down. It goes down, down, down. It's going to continue to decrease, but there's one number it's never going to hit, and it's never going to go below. It's never going to go below the x-axis here. It's not going to go below 0. So our y is always going to be bigger or equal to 0. It's going to keep getting close and close and close and close and close to that 0 as we go left, but it's never actually going to hit 0. All right, we have one more problem to do. Okay, so number 2. You guys are crushing it. All right, number 2, we have h of x. Remember, that's just another fancy way of saying y equals. This time we can just call it function h. It's helpful to do if we're going to have lots of graphs on one graph. We're putting them on separate graphs, so it doesn't really matter. Okay, h of x equals 4. Times, and then in parentheses, we're going to have 1/3 to the x power minus 2. So in order to determine if this is a growth or a decay, we're looking to look at our number that's taken to the exponent. So which number here has that exponent? The 4, the 1/3, or the 2? The exponent comes after the 4? It's actually with the 1/3. This is our b this time, because that's the part that x goes to, is just the 1/3. So if our b is 1/3, does that mean it's bigger than 1, it's growth, or is it between 0 and 1 and it will be decay? Where does 1/3 fit? Bigger than 1 or between 0 and 1? Yeah, between 0 and 1. So this one's going to be a decay. Okay, and that's just a way for us to check our work. There's not a lot of ways to check your work with exponential functions. All right, so now we have our table. We're going to do x. Instead of y, we say h of x. Just saying what is the output when we put it into function h. And we always use the same x's for exponential growth and decay. We're just going to use -3 all the way up to +3. Okay, so if you want to put that in there, always use these X's. You can, just as a side note. Okay, now we're going to use our calculator for that input-output. So I'm going to type in 4, parenthesis, 1/3. I'm going to make sure my parenthesis goes on the outside completely. Then we're going to have to an exponent. What's our first exponent we'll put in? -3. And then off to the side, we have a -2. Okay, so our first output is 106. Now, some people are going to look at this and you're going to say, is that right? Because if we're going to graph this, do we have 106 on our graph? Nope. But it is right. Remember, it's going to drop now really fast. So now when I change that -3 to -2, it should hopefully be something way far away from 106. And it drops quite a bit. It goes to 34. Still can't graph that quite, but that's okay. We're still getting there. Okay, delete -2 or put in a -1. We get 10. Can maybe guess where that is on our graph, so that's getting close. Now we're putting in 0, so delete -10, put in 0. We get out 2. Okay, so as we look at how it's decreasing. From 106 to 34, is that a big drop or a small drop? That's a pretty big drop. That's like almost 70. Okay, 34 to 10, is that bigger or smaller? Smaller, and then 10 to 2, smaller. So it's going to get smaller and smaller and smaller as we drop. It'll get closer and closer to a number there. So now we put in 1. Okay, remember we're rounding to the nearest hundredth, so 2 decimal places. So I have -0.66. The next number is a 6. So do I want to keep it at -0 and 66 hundredths or -0 and 67 hundredths? What does that 6 tell me to do? Yeah, it tells me to round. Okay, I know it was hard to read because I do have that whole thing in there, so it's kind of goofy. So -0.67, because the next number was a 6, so that tells us to go to 67. Okay, now instead of 1, we're going to put in 2. We get -1.555555555. So 55. We want to keep it at 55 or round to 56? Round to 56. Delete the 2, we'll put in a 3. Oop, this one changes. -1.851. So does that 1 tell me to keep it at 85 or change it to 86? That would tell me to stay at 85. So -1.85. All right, then we're going to graph those points. So if you didn't glue in your graph paper yet, go ahead and glue that in. Does anyone need another one? You lost your second one? I got it. Thank you. All right, so here we go with the first one, -3, 106. Now we could, if we wanted to, count by something else on our graph so we could plot it. I'm not going to, so we just know 106 is like probably way off this page because it goes by tens, right? Or by sixes. I don't know. I'm not talking right. Even -2 and 34 is going to be way, like 34 would be probably like up here, be up in that other graph. We don't want to do that. So -1 and 10, we can probably estimate about where that is. So -1, here's 6, so 7, 8, 9. So maybe 10 is about here. If you have enough space, you can maybe guess where that is. So -1, I did 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10-ish. Okay, 0, 2, so 0 and then up to 2. Now 1, -0.67. Now with negatives and decimals, it can get a little tricky, so I want to think I'm going to 1. I don't want to go all the way to -1, but I do want to go more than halfway, because our halfway would be 0.5. So a little bit further than halfway to -1. but not to negative 1 yet. Okay, 2, I have negative 1.56. So I want to go to negative 1 and then go about a half more. 0.5 is about half, maybe just a tiny bit over half if we can. Okay, 3, we have negative 1.85. So we're going to negative 1, and then we want to go 0.85 more. So I'm not quite to negative 2, but I'm getting pretty close. Okay, I'm going to use blue with my decay personally. If you just want to use your pencil, you can. But as we connect this, remember we're going to do it as a curve. So it's coming down, it's going to curve, and then it's going to flatten out a little bit. Keeps going to the left or right, it's going to keep going down, but it's going to get a little bit flatter as we go. Okay, and that's that decay. So on this one, if we do our domain and range real quick, because that is on your test, which is on Wednesday. Domain is asking, does it keep going left and does it keep going right? So does it continue to go left, left, left? Yeah, it keeps going left. It's going up. It's going to be really crazy uphill left, but it does keep going left and it does keep going right. So our domain is still all real numbers. Now our ranges are up and down. Again, does this one keep going up? Yeah, we can see this up arrow, it keeps going way up. But as we go down, it is going to continue to go down, but there's a number that it won't ever cross over. Which number does it, as it goes down, is it getting really, really close to, but it will never cross? Yeah, negative 2. So we're going to say y and negative 2. And is our graph above negative 2 or below negative 2? Our blue line is above. So we're going to say greater than or equal. Actually, it'll just be greater than, not equal to. Sorry, should have erased that for the first one too. Just greater than. It's never actually going to hit negative 2. If you don't know that part, that's okay. That's something right now we're just trying to identify where that is. So same thing on the top one. It should have just been y is greater than 0. But if you have it the other way, that's fine for today. All right, that is it for your notes today. We still do have about, not quite 30 minutes, but we're close. Okay, so lots of time to get caught up on notes.